Hey guys, we're going to go over 242, which is valid anagram. So this problem is really cool because there's two ways to solve it. One is the naive or kind of easy way to do it, and that's just simple sorting. So if we think about our problem, it's asking us, given two strings s and t, so s being one string and t being another, return true if t is an anagram of s and false otherwise. So what is an anagram? An anagram is basically just a collection of characters or letters, and they're basically the same string just with rearranged letters. So think about cat. You can also have tac, TAC, and that would be an anagram. Or think about rat and tar, that would be an anagram as well. So let's take some of the inputs. So the first one is anagram, and the second one is Nagaram as one of the inputs. If we were to sort this, we would see that they are the same string. So let's make that a different color. So we have three A's, a G, N, M, R, and if we were to do the same second string, same thing, three A's, G, N, M, R, and then all you have to do is, for whatever your programming language is, you have to do the equivalent of returning string T is equal to string S. So that sorted string equaling S. Now for the more complicated solution, we're going to be using a hash map. So let's make that a different color. So for this hash map, essentially what you have to do is remember that anagram is just the same amount of characters, just rearranged. So the hash map is going to help with counts. So if we were to use the same letters, we would have 3 of A, we would have 1 of G, and we would the same for N, M, and R. They would all equal 1. Now, if we were able to go for the second string, we could just decrease that count. And if all the keys equal 0, then you know that those strings equal. If, however, one of the letters is less than 0 or greater than 0, then those strings are not equal. So, for example, let's use Nagaram. For the first letter, we're going to decrease it by 1. So that would equal 0. A, we're going to decrease that to 2. G, going to decrease that equals 0. R, decrease that's going to equal 0. Next one is R. Oh no, we already went through R, sorry. Oh, yeah, sorry, A. Now that's 1. Now we're at R right here, and that equals 0. And then A again, and that equals 0, and then M. So that equals 0. So if we were to iterate through the list again of these hash map key value pairs, and see that all the value pairs are equal to 0, then we would return true. Otherwise, we would return false. So again, all you're doing in the second approach, so approach number 2 is incrementing on string S. So you basically iterate through all the characters of string S. It builds up the counts of those characters, and then on string T, string T, you're decrementing or lowering the counts of those characters. So at the end of the day, we want to make sure all keys equal 0. If not, return false. If it all equals 0, then you return true. So let's just code this up. Of course, every one of these languages are going to have different approaches, but you'll see that for both the sorting and hash map approach, they're going to be similar. The only thing to know is with the sorting, it's going to be O log n time, roughly O or constant space. Now the cool thing with approach 2 is we're basically increasing the amount of space by using a hash map, but we're reducing that overall time, so we get a faster time. So instead of O or linear rhythmic time, ON log n time, we have ON time and ON space. So we are increasing space to increase time. Thus, I would, depending on the context, but I think overall approach number 2 is better. So let's code that up. We'll code both for all 3 languages. And yeah, let's go to the next part. Thank you. Okay guys, for the Java solution, we can do it 2 ways. So let's solve first the sorting way. So our sorting way will be just going through the natural like arrays methods and just sorting it and then seeing if it's equals. So remember, this would be O log n time because most sorting algorithms are in this time complexity, and we will roughly be doing it in O1 space. So one thing we have to check with all our solutions is just making sure that for this problem in particular, if the length of string s and the length of string t do not equal, then we're returning false because it can't be an anagram if they don't equal the same length. So we can just do if s.length does not equal t.length, then return false. Then before we can use the arrays.sort method, we have to change these strings into arrays of characters. So one easy way we could do that, SR is using it the strings to char array function. And same thing with the t string, change that into an array as well. And then we sort these. So arrays.sort SR. Oops. Arrays.sort.tr. And finally, we check if these arrays are equal. So dot equals SR and TR. So this will be our sorting solution for Java. Okay, now let's utilize or create our hash map situation. So this is going to be a little bit longer than the Python and JavaScript section because there is actually a simpler way to do the hash map. So for example, we're going to do the normal way. So normal hash map is going to be O(n) time, so a time improvement because we utilize more space to reduce that time. Space. And again, we'll just be utilizing the same thing. So if these strings do not equal, then we'll return false. We're going to create a hash map that will add characters and number counts. So we'll have character and then integer. Let's do pair or character counts. Make it simpler, so ch counts equals new hash map. Okay, from there we're going to be iterating for both of them. So if they're the same length, we can just do for int I0, I less than s.length, I times that. So then we can actually, when we're putting, we can check if it's right there or set a default. So if it's not there, it will default to 0, and then we can add it on the S string as we're counting new characters and decrement on the T string. So we can just do that using chcounts.put and the specific letter. Oh, char at, not get. So this, this char at method is in string, so we basically just index what character in the string you want to get. I can just do .get or default, and then this specific character And then if we can't find it, we're going to set it to 0. And also remember with this S string, we're going to increment by 1. And it's going to be similar with this T string, except we're going to minus by 1 and go for the T string. So the same thing, instead of the chart at S, will be the chart at T, and same thing, chart at T, and then instead of adding it, we're going to decrement it. And then after this for loop, we will have our hash map of character and count, so that key value pair. So we just iterate that using an entry set iteration. So if we use map.entry set, or entry, so in this case, again, it'll be character integer, and let's just make that M, and then we have our char counts dot, and I believe this is entry set, yep. And then all we have to do is when we're iterating through this, we get if M dot get key, get value does not equal 0, return false. And then if it goes for that whole hash map of character and counts, that key value pair, and they're all 0, then we return true. So this is a relatively, oops, let's see what I missed out here. Integer, I misspelled integers, I added that extra S. Okay, but this should work. Okay, so the one caveat is that we can actually, I think it's a little slow, we don't have to use a hash map per se. We can actually make that constant by actually just smartly using array of integers. So just think about like an alphabet, it's 26 characters. So we can just do char counts again, and then new int 26. So kind of same concept, where we're looking at each character, and then let's say A, that's like the first character, right? We're going to, for the S string, increment it by 1, and then for the T string, decrement by 1. At the end of this process, the whole array of ints should be 0. If not, return false. If true, return true. Okay, so instead of this hash map, we're going to remove that right there. Okay, yeah, so for this array of integers, all we have to do is call that right there, see counts, and then the specific string. So we have s.char at I, and then we minus it by that character. So remember, they all have their ordinal values based on ASCII key values. So I believe lower a is 91, and it goes all the way to like 120 something. But basically, if you like subtract it, you'll be able to get the index for this particular array, and you just add it. And then same thing for here. So instead of deleting everything, I will just refactor it a little bit. Minus minus. So basically, you go into this array of integers, and then they already default to 0. So you're going to increment it or decrement it. At the end of the day, they should all equal 0. So instead of having to do this for loop here, we just do a simple int I equals 0, I counts dot length, and then if g counts I does not equal 0, then you return false. And then yeah, you basically refactor it, but you made it less space because even though you're technically doing the same thing in the hash map. Alright guys, for this Python solution, I'm just going to keep it simple and do the hash map solution. So we're going to be aiming for this O n time and O n space. So there's something interesting here in the Python solution. So we can use just a normal dictionary, or we can even use an array of 26 slots that will represent an alphabet. Technically, we're going to be improving that by just using the constant 26 array of integers or listed integers, and just going through that. So it basically does the same thing. We iterate for the hash map or the array of integers, and if any one of those values of the character counts does not equal 0, we'll return false, else true. And of course, we're going to be checking to see that the length of S is equal to the length of T. If not, return false. And then let's do char counts equals this. So for I in range len S, if S I is not in char count S I plus 1 or equals 1, and then if it's there, then we'll just add by 1. So char count and then the same thing with the second one, but we're going to decrement it with the T string. Okay, so T right here. So this is the second string. Okay, and then so equals 0 equals -1. Let's just say that. Yes, because we want to delete it. Yeah. So for, I believe it is, yeah, I in range C count. If C count, oh no, it's not that, it's the characters, so we do key value pair enumerate. So in this case, key value pair enumerate CH count, and we don't really need that key, we just need that value, so I think we can just do this underscore. So if this value equals 0, return false, else return true. And sorry, a little bit of my job was leaking to Python, so let me just remove these semicolons. But this should work. Again, on this first pass on S, we are incrementing or counting up the keys, and then on the T string, we're basically removing those keys. And if all those those values equal 0, then it will return true. If one of those characters is negative or positive above 0, then it's return false. Or maybe this has to be 0. Okay, 1 second. Okay guys, so I'm just going to be refactoring this. I think it's causing the fail error. Okay guys, I'm just going to be iterating simply through the dictionary. So we'll just do this for a simpler one, and this should be simpler than the enumerate I was trying. And this should return true. And yep, that passed.